I've got all these equations here from the chapter. This is from the data sheet. And just remember, you don't have to leave them in this format. If you want to rearrange them for other things ahead of time, that's totally fine. Like you could have this solved for P1 if you wanted, or V, or whatever you're interested in doing. So this first question, determine the density of a gas. So density, and the symbol for density is either D or it's that rho symbol. And so as I look at these pictures over here, because I can see some other gas values, the only one that has that in there is this one, density. So we know that the molar mass is equal to the density times RT times P. And so I'm going to need to rearrange that one when I get to it. But I'm going to go ahead and write down my numbers. So blah, 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 blah. Then I see 299 Kelvin. So that's my temperature. Blah, blah. And then I see ATM. So 15.7 ATM. So that has to be my pressure. And then blah, blah, blah. I see molar mass. So that's that curly M thing. And that's 60.19 grams per mole. So I'm going to take my fancy looking equation. That's supposed to be density there. Or a rho over capital P. Now I'm going to multiply both sides by capital P. And then I want to divide both sides by R and T, because I've got an R and a T. I need the density by himself. So the R's cancel and the T's cancel. So if I clean it up a little, that gives me density is equal to that. So as I zoom in, I'm going to do 15.7 ATMs times 60.19 grams per mole. And then we have 0.0821 liters ATM mole Kelvin. And then we have T, which is 299 Kelvin. That's my density. So now I just need to have my calculator up. See if it'll let me put it on top. No. All right. So go back to here and get my quote up. There we go. All right. So I've managed to open up the wrong part of my calculator. There we go. Okay. 15.7 times 60.19 divided by 0.0821 divided by 299. So that gives me 38.5. And then if we're not sure on the units, we've got our ATMs cancel and our moles cancel and our grams cancel. And so we are left with 8 grams per liter, which is what the problem wanted. Notice that I have 1, 2, 3 sig figs there. That had 3 also. That one has 4. And that's a constant. We usually worry about those for sig figs. So there we go, 38.5.